15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again, and thank you for joining us on the Space Nuts podcast, episode 166. My name is Andrew Dunkley. I am your host, and joining me is astronomer at large, Fred Watson. Hello, Fred.
Hello. I'm trying to think of what might be magic about the number 166, and, well, it's, apart from the fact that it's quite close to my age, I don't really know.
Yeah, I think it's just another number, really.
It's just another number, yes. Yes.
We're a little way off 200, so we won't even start planning that yet. I'm thinking we should do it from the International Space Station. That's just
I'm sure somebody could arrange that for us.
I think it'd be easy. Now, we've got a lot to talk about. As usual, we are going to look at life on the moon. Yes, there is. Yes, there is. And it's not something that everyone's happy about. We also are going to find out what's inside a neutron star. Neutron stars have strange habits of doing things like slowing down and speeding up and then going back to normal speed again. They think they know why now. And a few questions. What is opposition? What's the difference between astronomers, cosmologists and astrophysicists? And what's our address in space, in the universe? We have an address, as it turns out. We'll answer all those questions on Space Nuts today. But let's start with the moon, Fred. There is life on the moon, but there's a bit of a caveat to this one because it's not native life. It's something that was put there.
Yeah, that's right. It's a very interesting story. So what's the life that we're talking about? It's part of a package of I guess what you might call genetic material to give it its widest possible coverage, which was sent to the moon on a spacecraft which you and I talked about, the Israeli spacecraft, which was sent there by a private concern. The aim was that it would touch down softly on the moon. But sadly, it didn't. It crash landed on the moon back in April. The spacecraft, I'm sure I'm not pronouncing it properly, but it looks like Bereshit or Bereshiet. That was its name.
Well, it's certainly Shiet now.
Yes, quite so. Oh, dear, oh, dear, oh, dear. This is a family show.
I'm stooping again.
Actually, no. Nobody in the right mind would let their family loose on this show, would they? So yeah, it's a lot of Israeli effort has gone into it. As I said, it was a privately funded spacecraft. Sadly, crashed on the surface of the moon. But what we found out is that it had on board, as I said, genetic material, including animals which these are not microbes, they're proper little animals, but they're the toughest things we know about. And no, they're not cockroaches.
They're far more cockroaches.
And they're far cuter as well. So I know about these things because they make a big appearance in one of the chapters of Cosmic Chronicles, the new book, which, by the way, went to the printers yesterday.
Woo, exciting.
So anyway, that's another story. So they are called tardigrades, otherwise known as water bears and occasionally as moss piglets.
I like that one.
Yeah, they're not the kind of bear you'll ever have to run screaming from because they're, even though they've got 8 legs, they do have 8 legs, each of which is equipped with claws on the end, but they're only 0.5 millimetre long.
They look like something out of Doctor Who.
Yeah, they do, don't they?
Yeah.
So moss piglets, I think, is a more descriptive name because they love to live in moss or lichens, and they do look like piglets. And they've got these really smiling faces, apart from the fact they haven't got a mouth or any eyes, but they've got puffy cheeks that make them look incredibly cheerful.
Yes.
So everybody loves them, the tardigrades.
They're super tiny, like
0.5 millimetre.
0.5 millimetre, yeah.
Yeah. So they swim around with 8 legs.
Which in American speak is really tiny.
Very small.
So I don't know what 0.5 millimetre is in imperial.
It's wait a minute.
A fifth of an eighth of an inch.
I used to know these things. Yeah, it's small. It's not that small, but it's small.
Yeah, it is.
It's well, let's do the calculations. 0.5 millimetre is a 50th of an inch. There you are.
No, I wasn't far off.
No, you went far. What did you say?
A fifth of an eighth.
Right. 25.4 millimeters to the inch is the magic number. And so half a millimeter is about a 50th of an inch.
And that's all we've got time for
it is. That's right. But going back to the tardigrades, what makes them interesting and why we talk about them in the context of astrobiology and spacecraft crashing on the moon is that they are incredibly tough. They can go into this state, which is almost like suspended animation. They can dehydrate themselves so that they contain virtually no moisture. Now, of course, water is the working fluid of all life on Earth. So if you take the water away, what have you got? Well, a corpse.
Yeah.
But I think you only need tiny, tiny quantities of water in the bodies of these things, and they go into this suspended animation state, which makes them basically just curl up into a ball, which has a name, which I'm struggling to remember at the moment, but doesn't matter. But these are basically dried out tardigrades. But when you drop them in water again, they just sort of say, "Oh, that's great," come back to life and start swimming around. And the reason why we know they're hardy is that there was an experiment done a number of years ago in which tardigrades were let loose on the outside of the International Space Station and survived. I can't remember the exact number of days. It is in Cosmic Chronicles, but I've forgotten the number. And brought back in again and rehydrated. And a significant fraction of them survived. They came back to life. Many didn't, but quite a few of them did. And,
so they were exposed to the vacuum of space.
Indeed, that's right. And the ultraviolet radiation as well of space.
So all the stuff that would kill us, they survived.
Yeah. I remember when the journal, the learned journal Nature published an article on this, and the headline was "No Spacesuits Needed for These Creatures." Which I thought was quite nice. So they can withstand the rigors of space at some level. It's not foolproof. I think, as I said, it wasn't all of them that survived. Maybe the ones that survived were shielded from the ultraviolet radiation of the sun or something like that, but they did survive the vacuum of space. And some of them went on to produce perfectly normal offspring. So because these are animals rather than microbes, so they actually, they do reproduce. So tardigrades have been thought of as, potential ambassadors of life on Earth on other worlds. And the Israelis have rather jumped the gun on this because it actually does contravene the laws of planetary protection, which you and I have talked about before.
Yeah.
The tardigrades are apparently encased in resin, something a bit like the amber that we used to sometimes find ancient prehistoric insects in and things of that sort. So the fact is nobody knows what's happened to them. The spacecraft, when it impacted the moon, almost certainly blew itself into pieces. And the tardigrades may have remained intact in that conflagration or explosion, or maybe not. We don't know the answer to that.
But the people involved are suggesting they probably are alive.
That's right, or at least in their dehydrated state.
Yeah.
Yes.
Wow.
So that is a possibility. We don't know how long they'll last, and neither do we know what the prospects are of somebody going to pick up the pieces to find out what's happening up there.
Be worth a look.
It would be worth a look. That's right. And, it's really rather an interesting scenario.
Even if Israel did break international law in doing what they did.
Apparently they did. That's right.
Allegedly. Okay. Well, I suppose we just have to wait to find out, and who knows if ever we will go and pick up the pieces and see if they're still okay, or some of them. I mean, it's just one of those things that's been left there to be wondered about until one day someone stumbles across it, perhaps.
We'll find out, that's right.
Yeah. What was that spaceship supposed to do if it had landed properly?
I think basically it was to form a permanent kind of memento to humankind, which is why it's got all these, this archive of human history and some human DNA and things of that sort on board. But it would have clearly, sent back images and scientific observations as well.
To which people would have replied, yeah, been there, done that, seen that.
Yeah,
hasn't changed colour.
Yeah, no, it hasn't. But no. there's still a lot to learn about the moon, Andrew, and we remain fascinated by the Earth's nearest celestial neighbour.
But right now, there is life on the moon, we think, and we put it there, and we shouldn't have. Sorry, I was being a bit Australian then. And,
Australian, yeah. Shouldn't have done that.
No. So we watch with interest. We may never find out, but hopefully one day we will. You're listening to Space Nuts. Andrew Dunkley here, and Fred Watson there.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, to the fascinating topic of neutron stars. These are quite small objects, but they are really dense. I mean, you ask them 1 + 1 and they just shrug their shoulders. They are very, very dense indeed. And now it seems rather accidentally, some Australian scientists have figured out what they're made of, because they have these strange habits, don't they?
They do. So neutron stars were first observed as what are called pulsars. And pulsars they were thought at first to be little green men. They were discovered by Dame Jocelyn Bell Burnell, who we had the pleasure of hosting here in Australia last year. But what pulsars are basically very highly repetitive bursts of radio radiation, sometimes only a millisecond long, but repeating on that sort of timescale, quite different from the fast radio bursts that we've talked about before, which are a total mystery. Neutron stars are known to be the result of these crazy, highly compressed stars which beam out radiation from their magnetic poles, and they rotate very, very rapidly. And so the radiation acts almost like a lighthouse beam. It sweeps out through space. And when the Earth is in the right position relative to one of these things, we get these succession of blips of radio radiation. The great thing about them is that they are incredibly regular, but it has been known for many years.
All the fibre they eat, Fred. That's. You didn't think I could stoop any lower, but
I was, well, just keep eating your prunes. You'll be all right. They're very regular. These bursts of radiation are actually more accurate than atomic clocks in terms of how regular they keep the time. Except that once in a while they experience something that is technically known, and this is true, it's technically known as a glitch. They speed up slightly and then slow down slightly, and then speed up back to the original speed that they were going at. There's like it goes slightly faster, very briefly, slightly slower, very briefly, and then back to normal.
And we're talking like periods of seconds?
Yes, I think so. Oh. I am not a pulsar specialist, but I think they're relatively short periods of time when these glitches occur, which is kind of why they're called glitches. Yeah, the particular one that's been observed that we're talking about today, the whole thing lasted 13 seconds.
Wow.
So you are talking about events that if you blink, you'll miss them.
We had a glitch at the radio station a couple of weekends ago that lasted 2 days. So
yes, that's right. You probably never came quite back to the normal speed, which the pulsars are very good at doing. So what causes the pulsar phenomenon? It's, as you said, it's neutron stars, and neutron stars are basically the most dense and gravitationally intense thing next to a black hole, because they're the result of a star collapsing on itself, so that the only thing that is withstanding the huge gravitational pull of a star's worth of material, the only thing that's stopping it collapsing to a black hole is the pressure of neutrons, that all the neutrons are jostling together, and they can just overcome the self-gravity of this thing, which wants to pull itself into a black hole. So that's kind of, the situation with neutron stars. A mass of a whole whole star like the sun, in fact, usually more massive than the sun, compressed into something 10 kilometers or so across. It just beggars belief that the density of
it
the
would
material.
be like your car running out of petrol and then collapsing in on itself to the size of a pea.
That sort of thing, yes. Yeah. Except I think it might be more like the size of an atom.
Yeah, maybe. Yeah,
because it's such a different state of matter that we're talking about. Now, theoretical astrophysicists, they study what might be inside neutron stars, and the structure that seems to fit the physics and seems to fit what we observe is an internal fluid of neutrons that in the middle, it's almost like a liquid, but it's neutrons, as I said, pressing up against each other. So the laws of physics that these neutrons obey are quite different from what a liquid would obey. But a liquid's it's a good enough term to use to get over the idea that it's not just a solid mass of neutrons, that they can move around relative to each other. But on the outside of it, there's a crust, a sort of hard crust, and that is where the intense magnetic fields play out that actually cause the material to beam out and give you the effect of the pulsar. So that's the theoretical structure of your average neutron star. But the idea of the glitches, what makes them, is something that has puzzled astrophysicists for many years.
Well, I suppose when you've only got like 13 seconds to see this, it would be very, very hard to detect.
Yeah, exactly. So it's the observers of pulsars over the years have spotted these glitches. We know that they happen, but finding one and predicting it, well, that's a bit different. So what's happened is a team which includes astronomers from Monash University, which is down in Melbourne, in Victoria, and from the University of Tasmania, which is even further south than Victoria. They used a radio telescope, which is actually in Tasmania. It's at a place called Mount Pleasant, which is very pleasant indeed, just outside the city of Hobart. It's quite a big one. It's a 26-meter diameter radio telescope, so it's not a piddling little thing. It's got a reasonable amount of sensitivity, and they watched one of the brightest pulsars in the sky, which actually our observatory, the former Anglo-Australian Observatory, had quite a lot to do with it. It's in the constellation of Vela. Vela, if I remember rightly, is the sail of the ship Argo. It's in a southern constellation. And Vela, we know, has the remains of a supernova in it, an exploding star, which generated at the end of its life a cloud of gas, which we can see and detect. We can see it in visible light and detect it with radio radiations, as well as this neutron star beaming out its radiation at the center. It's called the Vela Pulsar. And the reason why we had a lot to do with it at the Anglo-Australian Telescope in Coonabarabran, this is back in the 70s possibly, or certainly the 80s, I think it might be the 70s, was because the Anglo-Australian Telescope was the first telescope to observe this pulsar in visible light. We could see it flashing. And that, I think, was only the second optical pulsar ever observed.
My wife's just poked
got a visitor.
She's been yelling out hello for the last 5 minutes. Say hello to the space nuts.
Hello.
There you go. That's my wife, Judy. And
she's left in disgust. I don't wonder. So, yes, as I said, there's a connection with the optical astronomers, of whom I guess I'm a representative. Anyway, the astronomers were very patient with this telescope, and eventually they observed a glitch, and observed it in enough detail that they could build a model of what's happening, and that model has now been published in the in the learned journals of astronomy. In fact, Nature, which we mentioned just a few minutes ago. The idea is that, as I said a minute ago, the neutrons are just sort of squashed together, so they do behave like a liquid. but there are quantum effects, and that turns them into something known as a superfluid, which doesn't behave like normal fluids do. Lots of funny little, whirlpools, eddies, vortices, that kind of thing. And the suggestion is that you've got different layers of this superfluid within the rotating neutron star, and sometimes the stuff in the middle actually gets flung outwards to hit the hard crust of the star, and that makes it spin up faster. And then there's a sort of catch-up which slows it back down again, and eventually it returns to its normal speed. One of the
sounds simple, really, when you think about it. All this mystery, and it's just, a thing.
It's a thing, but of course, when you're doing these things, you don't just pull ideas out of the woodwork. No. You're looking at what the mathematics of quantum physics predict might happen to a huge mass of stuff like this. Anyway, it's excited Pulsar and Neutron Star astronomers, and I think what everybody wants to do is wait for the next one, so that there might be another glitch that maybe would confirm the theory that has been built around this.
Yes, because as you and I have discussed, see it once, maybe it's something. See it happen twice. Aha moment. Right. That's what we're waiting for.
Indeed,
but it certainly seems like we've got a bit more of a clue about how these neutron stars behave and why they do the things they do, which is, a rare thing when we get an answer to something that's happening way out there.
Exactly. In neutron star astronomy, the difficulty is asking the question, because they're so bizarre.
Yes, they are. They're very, very strange indeed. Anyway, we'll wait and see if they can catch another one very, very soon. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson.
3, 2, 1.
Space Nuts.
Now, Fred, before we move along to some questions, I need to shout out to Carrie Brown. Carrie is someone who's asked us a couple of questions in recent times, but she came to me the other day and said, I want to start a Space Nuts podcast group so that Space Nuts fans can all talk to each other, which I thought was a great idea. So I went to our producer, Hugh, and before I could even ask him the question, he messaged me. This was the very next day, and said, I'm thinking of starting a Space Nuts podcast group. And I said, well, you need to talk to Carrie. And so they've spoken to each other, and now we have a Space Nuts podcast group on Facebook, and it's called the Space Nuts Podcast Group. So if you would like to join and talk to other people that listen and maybe get to know some of the space nuts that have been following our podcast for so very long, find the Space Nuts podcast group and ask to join. I'll say yes, I don't care. I'm supposed to vet everybody, but I think most people who'd want to join a group like that are pretty genuine anyway. So have a look for it, the Space Nuts podcast group on Facebook. And join up and get to know some of your fellow space nuts. And while you're at it, maybe have a look at the Patreon page, patreon.com/space nuts. Fred, we have now got 37 patrons who are supporting our podcast, which I think is fabulous. And thank you to everybody who's been willing to spend a couple of dollars a month just to throw into the coffers so that we can keep going. We didn't ask for this. It was an idea from one person, and it's sort of grown from there. So it is fabulous. I really appreciate it. And so does Fred and everybody involved. So it's fabulous. Now, Fred, we've got some questions to get to. Hi, Andrew and Fred. I wonder if Fred might be able to get my head around the astronomical term opposition. If something is in opposition to the sun or the moon, is it on the opposite side of the visible sky, or is it on the opposite side of the planet? That's a question that's come from Denise Challenor. Hi, Denise. Thank you. That's a great question.
It is. It is a great question, because it goes to the basics of observational astronomy, and the answer, usually what it means is when an object is on the opposite side of the sky to the sun. So, for example, when Jupiter is in opposition, it means that as the sun sets, Jupiter rises.
So I would have witnessed an opposition this morning when I was on my way to work. I saw the moon setting and the sun was about to rise.
That's right. So we call that we give that sort of opposition a special name. We call it full moon.
There you are.
In a sense, though, Denise's questions, she said exactly what it is. Is it on the opposite side of the visible sky? Yes, which means that often, when you see Jupiter, when it's at opposition, you can't see the sun because it's below the horizon. It's at night time. That's fine. But it also means that, exactly as she says in the second bit of her question, is it on the opposite side of the planet? Yes, it is, because our vantage point is from the planet. So we're seeing it on the other side of the planet. But it really means it's opposite the sun. I was going to say the opposite, which is the wrong word, but the antithesis of opposition is something called conjunction. And that's when two things are close together in the sky. So opposition is when something's opposite the sun in the sky. Conjunction can be either something being close to the sun, and that happens with Jupiter as well when it's on the other side of the orbit, or you can talk about the moon and a planet being in conjunction, or a planet and a star. Things getting close together in the sky are called conjunctions.
And if you look at them for too hard and too long, you get conjunctivitis.
Conjunctivitis, exactly. That's where it comes from. Yes. Oh, gosh. You see, we do everything in this show. We do medicine and hocus pocus and mumbo jumbo. Pity it's all rubbish, Andrew.
There's a lot of mumbo jumbo. It's the most important thing on the planet. Keeps us sane.
Yeah.
Okay, so I think we sorted that one out. That was pretty easy.
Indeed. And it kind of leads into the next one, because what I was about to say was that is basic astronomy. Is what we've just been talking about. So now you go to the next question and people will understand why I mentioned that.
Now, this comes from Dan of Gorican, but he formerly lived in Dubbo, which is where I am, in central west New South Wales. And there's a bit of a personal connection between Dan and myself, as it turns out. Hi, Space Nuts. Thanks for creating such a brilliant podcast. Is he talking about ours, Fred? The way Fred can explain mind-bendingly complicated ideas and concepts in such simple terms, he's a simple man, is a true and rare gift, and Andrew's humour often makes my sides hurt.
Makes mine hurt as well, Dan.
There's a pill for that. There's a pill for that, Dan. I recently played my mother an episode to which she replied that she knew Andrew quite well, as his children attended Rainbow Cottage, where she worked in the office. I think I know who he's talking about. I've got a picture in my mind. I was hoping Fred could explain the difference between astronomers, cosmologists, astrophysicists, etc., as I feel as though I have underestimated what an astronomer does. Space Nuts is the best podcast on the internet by far. Dan only listens to one. But, thank you, Dan. We appreciate it. Good question.
It is a great question. And it's one that, I'm glad has been asked, because we've never talked about this before.
No, not really.
And, we see, when we watch the media, we see these different terms that are used to describe people. Whereas once upon a time, we would have all been astronomers. The word astronomer, actually, astronomy, the science, comes from, it's Greek, I think. Astro is star, nomo is number. So it's about numbering the stars. Which differentiates it from astrology, which is, when you break it down into its Greek, it's words about the stars. Ah. So astronomy technically means counting the stars, but actually, of course, it means anybody who studies the stars. Now, in the 1860s, the late 1860s, we could suddenly work on the physics of the stars by analysing the light from stars. It was a man called William Huggins, who was an English astronomer. He basically invented the science of astrophysics, because he devised the way that you could break down the light of a star and reveal its component elements and the physics of what was going on there. So that was when astrophysics was born. And then, a lot of people started calling themselves astrophysicists. I don't know. I always think astrophysicists, when I hear people introducing themselves as an astrophysicist today, it sounds slightly pompous to me, because basically what you are is an astronomer who's doing physics. So most astronomers are astrophysicists as well. So you needn't necessarily delineate yourself as, oh, I'm an astrophysicist.
Well, to drag our program even lower, the current bachelor on the Australian version of the show is claiming to be an astrophysicist, and I think he runs a petrol pump. I don't know. I'm just going.
That's slightly. I've read a little bit about this gentleman, and yes, he did study astrophysics, but he's not doing it at the moment.
No,
but he has an interest in.
He's a checkout chick or something.
Planetary. I can't remember what he's doing, but it's planetary.
He seems like a nice bloke.
He does. He seems like I should explain, Andrew, that I've never seen the show that he's part of, but I did see a news item about him, and I thought, yeah, it looked like a nice.
Be going by the promos.
Yeah. Well, you're watching the wrong channel. That's your problem. Anyway.
Probably channel surfing.
So an astrophysicist is, in many ways, just an astronomer, but with a fancy title. And the same is true, I guess, with the other specialisms within astronomy. So you get to more and more specialist ideas. So a cosmologist, which Dan's asked about, is somebody whose special field is the origin and evolution of the universe. That's what cosmology is all about. An astrobiologist is somebody who's interested in the origin of life and how life might be found throughout the universe. But they're really all lumped under the heading of astronomers, or if they feel so inclined, astrophysicists, because they're pretty well astrophysicists as well.
In real terms, all jokes aside, an astronomer is more of a broad spectrum role.
Maybe that's right, so I've always called myself an astronomer because I try and do a bit of everything. And astronomy is the topic that has fired me up since I was a kid, with some fairly big helpings of space science as well, which is now a different branch of it. 100 years ago, astronomy included studies of the planets as well, but now that has become space science or planetary science. The topic has broken up into its subcultures, if I can put it that way.
Fantastic. All right. Hopefully that solves your dilemma, Dan, and thanks for asking the question. And say hi to your mum for me. Tell her the kids are doing well, by the way. They are really flourishing. Very proud of them. So we'll move on to our next question. Hi, Fred and Andrew. How are you both? I hope you're well. Yes, we are. End of the question. That was the question. He says, I've just signed up as a colonel on your Patreon account. So a very worthy cause, I think, he says. So thank you for that. Oh, we really appreciate it. I have been interested in physics, astrophysics, particle physics for a very long time, but only really got into it once I read Stephen Hawking's popular published works and started listening to Space Nuts and Space Time, our sister program. With Stuart Gary. I am interested to know what kind of exact address from Earth in terms of where we sit in the galaxy, speed and motion, and then the local group, Virgo, supercluster, outside our supercluster, obviously, and any nearby voids, supervoids, and how those things may be moving, and if the universe itself is turning, spinning, as well as expanding. Now, that's a question I've never thought of. Is the universe actually spinning while it expands? So that is the question. Anyway, please let me know when you can put it on the show. Right now, Andrew Mortimer, that question comes from. So, he's asked quite a super cluster of questions, really.
Yeah, that's right. And it's a good question because our picture of where we are depends really on the framework that you're looking in. So yes, we can easily identify our position on the surface of the Earth by latitude and longitude, and that actually means that we've got a speed as well, a speed of rotation about the Earth, which is actually around about 1,600 kilometers per hour on the equator. At the latitude where we are, Andrew, it's roughly 1,450 kilometers an hour. We're going eastwards at that speed. And of course, the nearer you get to the pole, the lower the linear speed is. So we're already talking about a movement that we don't feel, and that's because of gravity. And so on. Then you can say, well, all right, the Earth is the third rock from the sun. It's orbiting around the sun. It's got an orbital motion which is about 30 kilometers per second. So the Earth moves through its own diameter in about 7 minutes at that speed. It takes, it's pretty fast.
Yeah.
So relative to the center of the solar system, we're also moving. We've also got an address, and then we are in a different place relative to the center of our galaxy. We're about halfway between the galactic center, excuse me, and the outer boundary of the disk of our galaxy, this disk of 400 billion stars and gas and dust and other stuff. So we are also rotating about the center of the galaxy, and our speed in that context is round about 250 kilometers per second, roughly, around the center of the galaxy. So you've got this picture of, the us moving on the Earth moving around the sun moving around the center of the galaxy. And there are other motions as well, relative to big clusters of galaxies and voids, which is, what the question was about. But I would tend to sidestep all that, because there is a really interesting sort of fundamental motion that we can measure. And it comes about because of the way we see things in deep space. Now, you and I have talked before about the cosmic microwave background radiation.
Yep.
Which is the flash of the Big Bang. And it's in all directions and is really very uniform all around us. What's happening is we're looking so far back, we're looking so far out into space that we're looking back to a time when the universe was still glowing. Because the expansion of the universe, that glow is now in microwaves rather than in visible light. But that's what it is. It's still, when it set off on its journey, it was blindingly white light. Now it's microwaves. So we're in the center of this sort of bubble. It's an optical illusion, in fact, but we can see the cosmic microwave background radiation all around us. And it's an optical illusion because you're looking back to an earlier time, which, has long gone. But what you can do is you can measure the sun's motion relative to that background. And that is a really fundamental number. It tells you that we're moving through space, and what we're moving through is something that you might call the standard of rest of the whole universe, because it's in a sense the glow of the Big Bang, which might represent something much more fundamental than the center of our galaxy or anything like that. And we've got a motion relative to it, and it is round about 368 kilometers per second. So that is probably the sun's, that's the sun's velocity in respect to that. So that's probably the most fundamental address in a way that you can give. It's not an address in terms of a place, it's an address in terms of speed. I think that's quite a fascinating piece of information, that we're actually moving with respect to cosmic microwave background radiation. What does it mean? We don't really know.
Of course, you could have saved yourself all that effort by simply telling Andrew to go and listen to Monty Python's Galaxy Song. Would have said the same thing.
Indeed, it says the same, but it doesn't mention the cosmic microwave.
It doesn't. But the other question, part of the question was, is the universe spinning?
Well, it might be, and that might be what we're seeing with that, origin. The problem with a concept like that is, what's it spinning relative to?
Yeah.
And universe by definition means everything that you can observe or see. And we throw the term multiverse around these days, which kind of flies in the face of what a universe is, because a universe is supposed to be everything. So working out whether it's spinning or not it doesn't really have any meaning. If we do find that there are multiple universes, and there might be evidence for that comes from somewhere within the next few decades or so, if we could prove that and establish it conclusively, then we might be able to work out whether we are spinning with respect to these other universes.
That would be interesting.
We don't know.
No, we don't. But we do appreciate Andrew's question. He
right.
had plenty more to ask, which we've put in the too hard basket. We'll get back to that shortly basket. But thank you, Andrew, for the question. And thank you for your support on Patreon. We appreciate that. And thank you to everyone who's contributed to today's program and to everyone who's downloaded and listened to us. We certainly value that greatly. That's what it's all about. And thank you too, Fred. Another great program, and we appreciate your time.
It's a great pleasure, Andrew. I hope we can do it again sometime soon.
Oh, I'm thinking next week.
Oh, gosh, that's a good idea. Why don't we do that?
We'll give it a try.
Yeah, all right. Yeah.
Thanks, Fred, and we'll see you soon. That's Fred Watson, astronomer at large. And from me, Andrew Dunkley, thanks again. We'll see you soon on another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes and Stitcher or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.